3D bioprinting with bacteria is a newly developed technique. This protocol provides an easy way of constructing engineered biofilms 3D printed with bacteria. The main advantage of this technique is the ability to produce 3D printed biofilms using an inexpensive home-built 3D printer.
One possible application of our 3D printer is to create reproducible model biofilms that can be used to develop new antibacterial therapies.
Our 3D printing approach can be applied to any type of bacteria that is compatible with our alginate-based bioink.
Preparation of the bioink and the printing substrates are fairly standard procedures, while the 3D printing process, especially the calibration of the z-axis, is a crucial step that requires some practice.
Calibration of the z-axis height will influence the resolution of our 3D printer and is strongly dependent on personal experience. This procedure requires manual adjustments and is difficult to be described in a written format.
Connect a 200 microliter pipette tip to a length of silicone tubing and mount the pipette tip onto the 3D printer's extruder head as a replacement for the original extruder. Next, add 4 milliliters of a 5 molar calcium chloride solution to 400 milliliters of 1% agar dissolved in Luria Bertani broth, and supplement it with the appropriate antibiotics and inducers. Then, dispense 20 milliliters of the LB agar solution into each 150 mm by 15 mm Petri dish. Dry the dish for 30 minutes at room temperature with the lid half open.